Hello everyone. Good morning. Did we do the circular tanks last class? Hello? Hello? Did we do the circular tanks last class? Or the rectangular tanks we have done till now? This is the rectangular tank. Good morning. Did we do the circular tanks last class? Anyone? Hello? Am I audible? Downwards. DOS 6. Circular tanks did we do? Or rectangular tanks? Hmm? Ready? Okay, then we'll do with the circular. I think. Okay. Thank you, Himal. Let's share then. Okay. So for circular tanks, what we'll do? Today we'll go with we'll take a problem in circular tanks resting on the ground. So what does the question? Directly we'll go to the question, and what does the question say? That design a circular water tank for the following data, and the data which are mentioned is what? The diameter of the tank is 4 meter. Right. The diameter of the tank is 6 meter. Depth of the water is 3.75 meter. Then we have the tank rests on the ground. Tank rests on the ground using M30 grade of concrete. M30 grade of concrete we are using, and Fe415 grade of steel. See here in the question solution you can see that we have what? The given things are depth of the water 3.75 meter, we have the diameter of the water, we have water tank, we have diameter of the water tank, we have 6 meter, then we have the M20 grade of concrete and Fe415 grade of steel we are using. Okay, so we know that we have to take some this thing freeboard in a water tank. So obviously if your depth of the water is here 3 point, if your depth is given to be 3.75, obviously we have to assume some freeboard in the water tank. So that is we have assumed here to be it to be 250 mm. So here how much will be the height of the tank now? 3.75 meter plus we have the 0.25 meter freeboard. So the overall tank's depth will know how much it is, 4 meter. Okay, so that comes to be 4 meter. Now we have a maximum hook tension will be there due to the water which is on the tank. So that is how much? Gamma W into H into D by 2. So gamma W we know 9.81, H we know this is the height of the tank 4 meter. So that is, and D we know already mentioned to us the diameter of the tank to be 6 by 2. Okay, so ultimately we got our hook tension to be how much? 117.6 kilonewton per meter. Now the area of steel, once we know this tension, we can find out the area of steel required. So the area of steel required will be how much? The tension, hook tension capital T by sigma st, and sigma st we know how much it is? This much, 130. This thing you already know, sigma ST and sigma CVC for M30 grade of concrete. How much from table 2 and 3 you have to check it out. So you know that thing. So area of steel required now will be how much? T by sigma ST, and T we know, sigma ST we know. So how much we got? 905 mm square. 905 mm square area of steel is required. So we can provide 12 mm 5 bars at the rate 120 mm center to center spacing. Okay. Okay, one more thing. The rectangular tank which we have done, there did I show you it was complete now? It was complete or not? No. Did I show you the figure? Base slab we have designed now in the rectangular tanks. Huh? In rectangular tanks, did we do till the base slab design of the rectangular tank? Hmm? Are you there, students? Hmm? Hello? Last class in the rectangular tanks, did we do till the base slab of the rectangular tanks and also the figure? Did I show you the figure? We didn't do, ma'am. Okay, till where we have done for the rectangular tanks, Simon, can you tell me? Cantilever action we have done of the rectangular water tanks, the bottom portion. Cantilever action and the base slab. All are sleeping over 9:15, 9:30. Nobody is responding. After joining, you left over. I'm showing you. So we are doing what? This one have we done. This one, the base slab design, cantilever action, and the last one, the base slab design of the rectangular water tank. And this one, did I show you? This one, this figure for the rectangular water tanks after we have designed all these things. At the center, we have the area of steel reinforcement 10 dia bars at 210 spacing we have given the and 16 main bars we have taken 16 dia bars at 160 center to center. Then we have 10 Yes, and we have completed till cantilever and base slab we did not do. Okay, then we must do that. Sure. So this is the cantilever action we have. That means we have done till the area of steel required distribution steel for long wall, for short wall. We have done. So now we have to do the bottom portion was to be designed as a cantilever. The cantilever action for 1 meter. So we'll design that rectangular tank for the cantilever portion. The bottom 1 meter, which acts as a cantilever. So there you have pressure at the base is how much? Gamma W into H, which is gamma W this much, almost 10. So we have taken it to be 10 into 3.7, 37 kilonewton per meter square. We have bending moment at the base is how much? Half into base into altitude this much. So gamma W into H into small h. Small h was, I think it is 1. I drew and showed you. Um, it's not, it's not there now. So gamma W into H, the H was this one, the top here. Then we have into 1 by 3, that is 1, h was 1 meter, the bottom portion h total was capital H, small h was this 1 meter from the bottom, and the above one was capital H minus small h. Right. So this is bending moment at the base for the cantilever action here. Then we have how much? We have got our bending moment at the base to be 300, oh sorry, 600, 6.16 kilonewton meter. Okay, 600, sorry, 6.16 kilonewton meter. Now once we know the bending moment diagram, once we know the bending moment at the base, we can find out the area of steel required for this moment, for this bending moment. So that is given by how much? M by sigma st into J into D. M by sigma st into J into D. So M we know it is 6.16, sigma st is 130, J is 0.86, D is we have the this one, how much it is? 250. Okay. So that we have got it to be 220.13 mm square, which is less than the required our area of steel, minimum area of steel required. So minimum area of steel required is how much? We always take it to be 0.24%. So a minimum area of steel is 0.24% of the area. So that is B into D. B is per meter, so 1000. D is our 150. Let me show you this one. Okay, this one. So area of steel, minimum area of steel required is how much? 360 mm square we know now. And so that is this one area of steel is our area of steel for moment is this one. Okay, so minimum area of steel is 360 mm. So we'll consider this 360 mm square. Why? Because our this area of steel for moment which we have calculated, it comes out to be less than the minimum requirement of the steel. So we will take the minimum area of steel which is 360 mm square. Okay, now if we see the base slab, we can go for the base slab design. We can go for the base slab design, which is we will provide 200 mm thickness of the slab. This was your base slab at the bottom of the tank. So we'll provide 200 mm thickness of the slab, and then we'll consider the top zone to be 200, since we are taking it to be thickness 200 now. So 100 and 100 will have 100 and 100. So the minimum area of steel required is how much? 0.24% of the area B into D per meter width. So we have 240 mm square minimum area of steel required. Provided area. Hello? Hello? Yeah. So we were doing what minimum area of steel was this much 0.24% of the area being to D. So provide we will provide a diameter. We'll take a diameter. You may take it 8 mm. You may take it 10 mm. Bars at 200 mm spacing. It is up to you. And then we have provided this much. How much area of steel? 281.32, which is greater than this minimum area of steel required. So therefore, we will take this as our base slab. For our base slab design, the area of steel required, that means area of steel we are providing is this much. Okay. So now, since we have done our area of design for this slab also, we have determined the area of steel. Okay, so this is the figure from where this one. eh, This one. After designing, we have this figure with us because we know here in the section, this is the plan, this is the section. Here, the section we have 250 depth. This one, this side. Okay, 300 mm width of the this one, the tank's wall. Then we have how much, if you see the problem we have solved there also, this was the base slab, and on the base slab how much we have taken, we had taken on the base slab 8 mm bars, this one. These are the on the base slab we have 8 mm 5 bars, 200 mm center to center spacing here both side. Then we have, these are your diameters of the rods here. On both the side, half we had done this inner face and the outer face reinforcements. This is the plan basically, which is for 6 meter the longer span. This side is the shorter span. For the longer span we have designed, then for the shorter span also we have designed, that means the area of steel and the area, the diameter of this steel spacing we have calculated those. So area of steel here, along the longer span what we had taken, at the support what we had designed, that was the mean bars were 220 mm dia, 240 mm center to center spacing, and we had this much at the inner face. This is inner face, this is the outer face. At the support we have 20 mm center to center, sorry, 20 mm dia bars at 120 mm center to center spacing, and a spacing of 120 mm center to center. Then we have the distribution bars. At the center we have 10 mm dia bars, 210 mm center to center spacing. Okay, and also this one 240. This main bars again on the center we have 220 mm dia bars, 240 mm center to center spacing. We have then here along the longer, now this was along the longer, and we had also designed along the shorter wall. So for the shorter wall again we have how much, for the shorter wall we have again this distribution bars are 10 mm dia, 210 mm center to center spacing. Then we have the main bars on the inner face is 16 mm dia, 160 mm center to center. We have here on the outer face 10 mm dia bars, 210 mm center to center spacing. We have again here on the support on the shorter wall 20 mm dia bars, 120 mm center to center spacing. Okay, so this is a section view, and this is this side, both sides around the longer and the around the shorter. So this is the plan. So once you design the longer, shorter walls, etc., or the base of these, this one, the rectangular tank's base slab. Okay. So after that, when you see this diagram, you will understand like which one you have designed for how much spacing you have given, how much area of steel you have provided. You can show it here also. And also once you have done this, you can also check this figure also, and you can understand like which part was what, how much you have got the area of steel, how much you have provided for this support 1 meter. Okay, let me take your attendance till then. This section B. Okay, roll number, please respond to your roll calls. Roll number 94, 95, 96, 96, 97,
97, ma'am.
98,
96 is ma'am. 96 ma'am.
98, 100, 2, 110, 112,
Yes ma'am. 112.
115,
Ma'am, 115.
116,
Present ma'am. 116.
117,
Yes, ma'am. 117.
119, 121, 122, 123, 125, 126, 127, 128, 130,
1
130,
to 8. 1
128, 130, 132,
Yes, ma'am.
135,
Yes, ma'am.
137, 139, 140, 142, 147. Okay,
Yes,
Michael,
Yes,
ma'am.
ma'am.
147.
142, ma'am. 142.
Okay, Michael, Tasika,
Yes, ma'am.
Laishram, Chausson. Okay, um, 45. Enrollment 45. For 65. Sorry, 64. 65.
Yes, ma'am. 64.
65.
Yes, present, ma'am. Yes, present,
67.
ma'am.
Okay, 67.